Set N contains numbers between 2 and 6 inclusive. We have 2, 3, 4, 5, 6. Then the set N contains numbers 4, 5, 6, 7, 8. Okay, so whenever you have this equal to sign, it means those numbers are inclusive. So the question says if there's a universal set 1 to 10 inclusive, find n prime intersection n prime. That means find the numbers that are not in m, that are not in n and are common to both. The number that's common to n prime and n prime. Okay, so let's first of all, the first thing we're going to do is to find n prime. N prime means the numbers that are not in m, okay, but are in the universal set. So this is the universal set, and this is n. So we have 2, 3, 4, 5, 6. What are the numbers that are not in 2, 3, 4, 5, 6? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The number 10 is inclusive. Then n prime will be, where is n? 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. Now, what is the intersection? That is, what is the number? What are the numbers that are in these two sets, that are common to the two sets? The numbers common to the two sets, that's not this intersection. But if it was union, union means everything together. But this one is, those are just common to both of them. So 1 is common, right? What other number is common? 9. What other number is common to the two sets? 10. So only 3 numbers are common to n prime, n prime. They are 1, 9, and 10. Remember, prime means complement. That means the number that is not in the set n and the number that is not in the set n. That is the meaning of complement. Next question, question 13. A square has diagonal length of 10 centimeters. Find the perimeter of the square. A square has diagonal length of 10 centimeters. Find the perimeter of the square. Okay, a square is a 2D, a two-dimensional shape. Okay, and we're told that it has diagonal of length. It has a diagonal of length 10 centimeters. We are asked to find the perimeter of the square. Because it's a square, it means that all sides are equal. Okay, so how do we find the length? We can use Pythagoras theorem to find the length. So we have L squared plus L squared equals 10 squared. Remember, Pythagoras theorem applies to a right angle triangle. This is a right angle triangle because it's a square. We have 2 right angle triangles here. So L squared plus L squared equals the third side squared. Alright, so we have 2L squared equals 10 squared. Dividing both sides by 2, we have L squared equals 100 divided by 2. 10 squared is 100. And that will give us L squared equals 50. L squared equals 50. So what is L? L will be equal to what? The square root of 50. We can simplify further. But because that is not the end, it's better to simplify at the end. We are asked to find the perimeter of the square. So there is no point wasting time simplifying because you still have other things to do. What is the perimeter of the square? Perimeter equals to what? Length plus breadth times 2. But because we are dealing with a square, we can just write 4L. That means L plus L plus L plus L. L into 4 places. So we have 4 times, what's that L? Our L is square root of 50. So we have 4 times, this is third. How do we simplify square root of 50? You look for the numbers, the factors that can multiply together to get 50, such that one of the factor, you will be able to find the square root of one of the factors. to simplify. So it's not just about finding the factors. Looking for a particular number that we can find the square root, and that number will be what? 25. So 2 times 25 is 50. Then we can write it by saying 4 times, you bring out this 25. You find the square root, that will give you 5, and you'll be left with root 2. Okay, you'll be left with root 2. Remember, it's root 5, root 25 times root 2. Root 25 is 5, and you are left with root 2. There's a multiplication sign here. Okay, so that will give us 4 times 5 is what? 20 root 2. Somebody might ask, why are we multiplying 4 times 5? Yes, we can multiply it in surds. When you have a number and then another surd, you can multiply the number by that surd. Okay, you're not going to multiply this 4 by 2 anymore. Okay, because you are going back to complicating the matter. Okay, so you leave the root 2 there. You leave the 4. The 4 does not have any root, so you can only multiply it by the 5. So 4 times 5 will give you 20, and then you write your root 2. So the answer is 20 root 2. Next question. A variable p varies inversely as the square of q. A variable p, so let's write that, varies inversely as the square of q. Now, do you know where many students will get this wrong? They are not going to remember square of q. So they will remove the square. Some other children will just read this as square roots. So different things can happen at this point. We have to be very careful. So p is inversely proportional to the square of q. Okay, so that means p equals k over q squared. K equals, multiplying both sides by q squared, you have k equals pq squared. Alright, this is variation. Now you substitute for p and q to find k. What is p? P is 5 and q is 6. So we have 5 times 36. That gives us 5 times 6 is 30, 3 times 5 is 15, plus 3, we have 180. So k is 180. The next thing you will do is, we have the values of, if the values of p and q are known, find the value of q when p is known. So you will use the two values that are known to find k, which is the constant. After finding your constant, you will now substitute that constant and the p that is known to find the q that is not known. So these two will be used to find, this p and q known will be used to find your constant. Then you will solve for q. Alright, so we have, you rewrite the equation p is equal to k over q squared. What is p now? The new p is what you are going to write. The new p that you are looking for, the q. K is 180 and q is what? What we are looking for. Multiply both sides by q squared to eliminate your denominator. You have 1.8 q squared equals 180. Divide both sides by 1.8. You have q squared is equal to 180 over 1.8. Q squared equals, remember, always eliminate your decimal to be on a good side. You have 180 over 18. You have multiplied the denominator by 10 to get 18. So you have to do the same to the numerator. That will give you 1,800 over 18. That gives us what? 100 if you divide by 18. So q squared is 100. Q will be what? The square root of 100, which is 10. The next question, question 14. Make out the subject of the relation this. Okay, this equation, we want to make R the subject of the formula. So we have 1 over P equals B over T plus C over R. Multiply through by the LCM. The LCM in this case, because we are not dealing with numbers, we are dealing with variables, the LCM with PTR. Remember, the goal is not to find LCM. The goal is to solve this equation. So you don't have to start finding LCM. When you have this kind of question, even in fractions that have known numbers, you can multiply through by multiplying the denominator. Multiply the denominator and then multiply through by whatever you get. So we have PTR. We're working with PTR. That will be 1 over P times PTR equals B over T times PTR, where PTR is a common multiple, not necessarily lowest. Okay? So we are multiplying through by the common multiple. The common multiple is PTR. You can always use your common multiple to simplify your fractions. Okay, so we have TR equals PPR. We need to be careful here, plus PTC. Okay, so cross check your work. PTR, we have TR, we have PR times B, then we have PT times C. We have TR equals BPR plus PTC. So the question says make R the subject of the formula. So we have R here and we have R here. All right, what do? We bring all the variable we are finding to the left hand side. So we have TR minus BPR equals PTC. R equals T BP factored by factorization. Let's cross check. Bring our RT, bring our RT, BP equals PCC. Then R, how do we get R? You divide both sides by T minus BP. Divide both sides by T minus BP. Okay? BP or PB. Both are correct. So R equals what? R equals what? PTC over what? T minus BP. So this is our R.